Hi, welcome back to my chemistry lectures on Hess law. In this video, I am going to discuss about enthalpy change for chemical reactions. As you know that calorimetry cannot measure the standard enthalpy formation of hydrocarbons like C3H8. So, as you know that C3H8 is derived from its elements carbon and hydrogen elements. So, carbon hydrogen elements do not combine at standard conditions to form this propane. Then measuring enthalpy change of formation of propane quite challenging by using calorimetry. Hence, we go for another method is by using Hess law. What is Hess law? Hess law can be stated as the total enthalpy change for a chemical reaction is the same regardless of enthalpy change of reactants taken in different routes to form the products. In other sense, the total enthalpy change of reactants to form the products in the direct step is equal to the enthalpy change of the reactants to form the products that takes place in several steps. Let us consider here one example. Given in this diagram, A plus B are the reactants. Here, A plus B are Consider A plus B are the reactants. So A plus B combine to form C is the product. C is the product, right? C is the product is formed in direct. So enthalpy of the reaction in direct step is, we can write H naught R. So standard enthalpy of the reaction in direct step to form the product from the reactants is delta H naught R, we say. It has some value. So the same reaction will form to see indirectly, indirect route 1 here, indirect route 2. The product can be formed in two ways. Let us discuss indirect route 1. A plus B are the reactants combined to form a reaction intermediates F plus G. F plus G are the reaction intermediates. Since these reaction intermediates are unstable, and they transform into the products, stable products, we say. Here, when AB combine to form A plus G, delta H1 naught and energy change. And when F plus G combine to form product C, delta H2 naught, energy change. So, enthalpy change of the reaction is equal to delta H1, sum of the delta H1 plus delta H2 naught, equal to the total enthalpy change of the reaction. So, the same product can be produced in indirect route 2 when AB combine to form X is a reaction intermediate, then delta H1 naught energy released. Since X is unstable here, and X can transform into Y plus Z, delta H naught 2 here. Since X and Y also still unstable, they can transform into C product, then delta H naught 3. So, if you consider delta H R naught is equal to, so delta H1 plus delta H2 plus delta H3 plus. So, some of the enthalpy changes 1, 2, 3 is equal to enthalpy change for the reaction. So this is Hess law we can explain. Thank you.